Good afternoon, people. Good afternoon, people. Good, we're good. All right, let's just get straight into it. I got new glasses. They're gonna arrive in like 2 weeks from Specky Savers. Right, so get this thing here.
Take a look at the stream now and see if
Blood made a Q&A before he made the actual video.
Okay, assuming this is working, I would love to welcome everyone to this test stream. Basically what I wanted to do is I am planning on starting a project.
But I already did the first, I think the first 2 episodes, so I think I'm able to copy his project. I'll just copy his files and I'll just resume from like day 3 probably. Of course, my phone starts blowing up when I go live. It just always happens. Bro, I actually gotta mute my phone, man. Every single time. It starts only alright, anyways. So that should be it there. Right. Have I got his Freddy Fazbear? Bro, I'm not watching the new FNAF. Bro, I'm not watching this, man. Man, I seen the first one, man. It was no good. What, PG rated 13 when the actual game is 18? Why? Why would you do such a thing? Anyway, Cross from Zen, how are you doing? Right, we've done that day 2.
Start recording. Okay, we are going. So
right. I think I'm on day 3 then. I remember this content.
okay, we are back with a Q&A from day 3 of the test stream.
All right, buddy. Well, daily I need to get the source code, but I do not want to pay for it. How does one get it then? Handmade Hero, day 3, source code. I'm sure someone's... I mean, it's 11 years old. I'm sure someone actually... You actually went bald. I mean, if you can see this, yeah. Yeah, I did. I mean, it's not anything crazy. Just like another day for me. Yeah. Also, Craft from Zen, do you think I should put music on the stream? And what do you think? Music or no music? Like the lo-fi thing or whatever. So
That's really critical. All right, we are ready to start here. Look at that timer. Stream begins now, ladies and gentlemen.
there's no way he's still selling the source code 11 years later. What? you never noticed that music made a difference to streams. Interesting. Very interesting. If it goes to shit, I'll just write it all down myself. I'll just copy it from the screen. Mali racket. Hiatus? What does that mean? Oh, a break. Okay, cool. How much can it be purchased for? Curious. Are you a business? I am, yes. But I'm not going to tell you that I am. $18. Nah. That is mad. $18 for day 3 source code is mad. Well, it's the entire source code, but yeah. Let's see. Right. If he... Oh. He's got quite a lot of files there. If music gives you a better vibe for coding, then maybe it's a good idea. Actually, depending on the music, it does distract me, but for viewer attention, that's the key thing. Because really, in streams, if the streamer doesn't talk for a set period amount of time, people get bored. So the music is there to fill in the gaps. So, yeah.
Which is learn to code.
In a way, I'm out of water again. Yo, stream elements in the chat was good. I'll be back in a minute. I'll get some water. You always have some gaming or coding videos playing on background for whatever I'm doing. You know what? That's surprising. I couldn't concentrate on the code if I had another video in the background. If you can do it, fair play on you.
Code C on Windows. And I'm going to go to the chat window now, and I'm going to take about 20 minutes of questions.
Oh, Oh, so he does the Q&A and then the actual content. Makes
Okay,
sense.
welcome everyone. This is the third day of the test stream here where I am sort of practicing to make sure everything's working properly and so that everyone kind of can give me feedback on how the streams are going in preparation for Monday's start of HandMade Hero. And so what I wanted to do today, if you remember where we left off, I was just showing you some assembly language and starting to talk about what the C code was actually doing. Today, I hope will be a pretty exciting stream. I am hoping that
All right, buddy, he's waffling so much.
and hope a coherent sort of model that you can use in your head, because I need
Entry to pointers, virtual memory, memory pages, that's good. I wanted to learn about memory pages for quite a while now. That's good.
to kind of get some things out there to really start from scratch in that sense. You kind of have to give you a little bit and then go back and go, okay, now that you've sort of seen some things.
Thing is, I can't actually see the full source code. Or can I? No, because he hasn't scrolled up all the way.
Let's actually talk about the holistic view. So
should be fine.
what I wanted to talk about today, finally, was memory. Because memory is actually the fundamental thing that we work with in programming. And the reason that I say that it's very fundamental is because even though nowadays in higher level languages we start to work with abstractions and things like this where we're not really thinking necessarily about the memory that we're using or what it's doing, the important thing to remember is that a CPU itself, the thing that we are actually programming, and a GPU for that matter, if you're working on a graphics card, those things are all about taking in memory, modifying them, and putting them back out to memory. This is true to such an extent that actually anything that you want to do, I don't care if it's audio or video or things that seem completely...
You don't like to watch videos where the person yaps too much, too fast, or too loud. You know, I agree.
They are actually all just about putting things into memory where other things can see that memory and use it. So if I want to do graphics on a graphics card and there's all this hardware in there that's designed to turn things into images that go out
My
on,
hair is gone.
even an analog, old school to a CRT or something where there was no digital transmission even. Everything that happens up to that point is about putting the right stuff into memory so that that hardware component can read the memory and turn it into the proper electrical signal to produce a picture on a television or something like that, right? So fundamentally, programming always comes back to understanding what is happening with the CPU and the memory. What is the CPU doing to change that memory and how? And that is the basis for all of the design of the code that you should do. You should be thinking about that because that is what you are doing at a core level. That's the basis of all the optimization of the code you will do. And it's the basis of all the debugging that you will do. Because absolutely everything at the end of the...
My friend, please. Please, my friend, can we stop waffle, please?
day is a CPU instruction that changes some memory. So nothing that you ever do, no matter how abstract, can...
Mikash, 1 second. Can you explain that profile picture on Discord? Because it's a bit concerning.
ever really get away from the truth of the matter, that it is all about modifying memory. And so there are definitely abstractions that help us, and we will be doing a lot of abstracting as we go. Oh my God, here are the actual instructions that the CPU have, and we added one to it. It was very exciting. I know everyone out there was psyched. But I was very heartened to see that actually people were pretty excited when we opened up the assembly language window, when I actually ran to this line of code here.
Ooh, I forgot how to do that. How do I open up the assembly language window?
And I went to go to disassembly here.
Go to disassembly.
This line of
Go to disassembly. I do not have that option. Enable address level debugging. Yeah, I got that one. Once enabled, start debugging. Oh, I need to add a breakpoint, I believe. Let's check this out. Right. And then go to this assembler. Where is that? There it is. Cool. Right. Well, that's great. So we have two movs. So I think that's the memory address. Got move into this register 0FFH. That means 255, right? Yeah. 2 decimal. Yeah. Okay. Well, check the DMs if you want to see context. You know what? Assembly isn't that hard. I mean, that's pretty simple. That's the memory address. That's the move keyword. That's the register. And that's the value of the variable. Easy peasy. Let's see this. The guy above doesn't know English, and his friends are telling him what to say. The girl on the bottom is an English actor on Zoom.
It's everything.
It's Chain.
Can you explain?
Everything.
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 Yes.
Yes.
Of course.
For example,
Оброс.
Оброс. Я хуёво подстрижен, скажу.
well, I don't understand. Can you explain?
I can't. I can't.
Like can't.
Come.
You
Bro, why is
love
your eyes all
cum.
like that?
can't explain?
I love can.
Small dick
Small dick.
in my ass.
In my ass.
Okay. I can understand these are some phrases. They are not.
Okay. Guys, let's turn this into a YouTube scrolling channel.
Code here, and I went to go to disassembly here, and I showed that here are the actual instructions that the CPU is executing.
That's what I'm saying, brother. Return 0. Right. This is one line. XOR is a bitwise operator. Well, I know what XOR means, but why are we using that here? EAX. Right. Register. Yeah, but I don't get why it's using XOR. It's XORing EAX by itself, yeah, but why? How are you going to XOR a register? What? It's the primary accumulator. Ah, right. It's the accumulator. I wonder, what's the arithmetic logic unit? Is it just ALU? It's just ALU. No, add. Oh, RO, LDI, ADC. What the fuck, bro? Bro, there's so many words. I just want to know what's the register code. I accidentally just closed that. Right. We're good. You XOR the value of the register, not the actual register. Ah, right. Okay. That makes sense. Now, follow-up question. What's the value in the XOR register? No, what's the value in the register? Well, it should say, actually. It's 1. Okay. So if it's currently 1, I'm guessing, because it says there 1, XOR 1 would be one of them. Only one of them must be. One of them must be true. So then the answer is like true. Yeah, 1 XOR 1. Being able to code on assembly on Windows. Bro, this is like the OG code. No, but what did he use to code? What did Linus? Yeah, but what did he actually use? Like before Linux? Okay. What operating system? Minix, that's it. Okay. That's the answer that I was looking for. Minix environment. So who made Minix? Right. Right, who's that? Andrew S. Tannenbaum. Okay. So they're all Unix based. Basically everything is Unix based. Yeah, so he made the operating system in this Minix operating system. Seems like it. Good. Can I edit the register? No, I can't. Minix, yeah.
So I found that very heartening because I'm glad to see that people were interested to see that, because honestly, I think that stuff is fascinating too. And that's the sort of stuff that I want to sort of sprinkle throughout this series so that people get an idea of what's going on. Now, before I do that, I'll notice there were some warnings in our compile there. I'm going to rebuild it so I can see what they are. Yeah, you can see. So our
Okay, that's the full code. Okay, good. So it hasn't done that much, right? Windows.h, let me just do it all from the beginning, right? So include studio. But do I have that? Oh, I do. Really? I didn't know that we have this. One sec. That is interesting. So this is studio.h, right? Here it defines EOF, end of file, I think. Seek cur. Right, I'm not sure what this does. Does anyone know what studio.h does? crazy. How many? 2,000 lines of code is mad. Did bro just notice only now that I've got YouTube Premium? Terry Davis, our beloved. I aspire to be like him. Yeah, Mika, that's what happens when you get a job, unfortunately. Sorry, I forgot to censor the word out. A J-O-B. Trigger warning there. A bit late, but... Alright, so... We got... I don't need to write that, I know what it bloody is. Void... Foo. We don't need to do that, really. I don't know why is he putting in void? That's like default anyway. Tell me if you guys can see the text clearly enough. If you can't see enough, there's nothing I can do about it anyway, but... Right, so explain what the A is next time, also N. Anyways. Foo, so we're getting a pointer to this string. This is the first thing we have printed. I'm getting pissed off. Why have I got an error? Bro. Bro, I'm actually speechless. Look at this. Look on this line right here. Car pointer foo. This is the first thing we have printed. Now, why does it work on his PC but not mine? What's going on here? Bro, mic's gonna crash. Oh. Bro. I lost it a long time ago, man. Bro, why the fuck does he's got the same line of code as me. Car pointer foo equals, in quotation marks, this is the first thing we printed. And it works on him but not mine. Bro, should I just jump out the window right now? Right. I'll put debug string A. Long pointer C style string. How many stories is your house? Wait, do you include the ground floor? If you include the ground floor, it's 3. If you don't include it, then it's 2 and a ground floor. And I'm at the top. Jump out. Bro does not want to see Code Gabe anymore. You're gonna survive. All right, buddy. Blood is on Windows, so why didn't he put \r? Bro, if this guy doesn't make sense one more time, I'm gonna do something. I'm gonna do something. Like, this is the third time where his code makes no sense.
Our compile has some warnings, and they're all about unreferenced local variable. And the reason for that is because you can see we defined a bunch of things here because I was trying to teach you about the different sizes that you can use for variables that you store. And since we never reference any of them, you'll notice that the compiler is sort of giving us a little warning and saying, hey, you defined something here. You said you were going to talk about a particular value, but you never talked about it. Was that a mistake? So it's a warning. It's not an error because it can still produce the code just fine, but it's a warning to let you know that. So what I'm going to do here is I am going to delete this for the time being. Or actually, you know what I'll do? I will use a comment because I haven't taught you about if-defs really yet. So I'm just going to use a comment to get rid of that. So that's gone now. It's commented out. And now when I compile, I won't get any warnings, so they won't distract us from what we're trying to do. All right. So the first question that I want you to ask yourselves and that I'm going to answer, or hopefully try to answer for you, is I told you what this did. I said char unsigned test was going to give us 8 bits that were going to be treated in an unsigned fashion, meaning that if I was to add 1 to the highest value, which was 255, it would wrap around to 0. I could not represent negative numbers. There were no negative numbers involved. So it has no...
Bro, I'd rather do this with pen and paper than have that white background on my screen. Imagine having a white code editor. I mean, look, even with the Python idle, I put it on black mode. See, because black is better than white. So
sign to it. It's always positive or 0. And
why the fuck isn't it working? I've got exactly what he has. Right. So he just deleted my foo string like nothing ever happened. Not the clanker again. Clanker's the only thing that's actually gonna talk to me. It does work. No, it doesn't. No, it doesn't. Look, I know the fix. I know the adding const will fix it, but I don't want to do that. We love clankers. Your compiler's code in C++, not C. In C++, strings libs have type blah blah blah, so they decay to const char. You cannot assign a const char blah blah blah. Blah 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 blah. You don't need to modify the string. Oh. Okay, let's change it to .c at the end. Ah, it works now. Cool. Cool. Now the only difference is that I need to use lowercase w. If that fixes it, I'm actually going to punch my PC. Okay, good. It didn't fix it. So I don't need to punch my PC. All good. All good. I'm going to crash out. stdio.h. Mika, help me figure out what's the difference between my code and Blood's code. What is the difference? You'll donate $1. Now, if you do it before, mate, I'll do it. $20 is $20. Do anything for $20. That was a joke.
What I want you to ask yourself, though,
Bro, you don't even have $1. You don't have a job. You don't have $1.
is
Silly
where
boy.
is that value? Where are those bits?
You know what? Fuck this guy. I have the exact same code as him. Ah, that's my bad. That is my bad, gang. It's my bad. So, project properties, linker, system. Yeah, okay. Yeah, that's my bad. Wait, what? Anyways, so let's try this again. Hello? Okay, the build succeeded. Why does Stream Elements ask to manage my account? Bro, just let it. Honestly. Just let Stream Elements is the goat, man. Just let it be. Let it be. Inconsistent annotation. Whatever. How do I get you to shush?
right? I said there were 8 bits, there were 8 ones and zeros, but where are they? And the first thing that we can actually do to figure out where they are in some sort of, rather topical sense, is when I come in here to the code. In fact, you know what? I'll just do this in code for you because I want to introduce these anyway. I'm going to introduce a new thing here, which is a pointer, and I'm going to run.
You fucker. You already introduced pointers. What's this? What is this right here? Pointer for you. Already introduced pointers, man. Oh my days. No, do not donate, please. Mika, you're like 13 years old, man. But this guy, right? He says he hasn't talked about pointers, but right here. What's this? What's this? It's a pointer, mate. You know, maybe this is just my autism, like playing up. But
On that here, so that we can inspect the values. So you'll note I've set a breakpoint again. I told you how to set breakpoints last week. I've set a breakpoint and I've stopped on this line of code. And what I want to show you is this new construct that I've created here, this new line of code. And you know what? I'm going to even go one further than that and break it out in a separate line because I don't want to talk about inline decorations yet. So there we go. Sometimes it's easy to get ahead of myself because I'm like, oh yes, I'll just do this thing. But it's like, I haven't explained that yet. Let's not go there. So anyway, what I want to show you here is that in C, and this is a departure from a lot of languages that people program in these days, in C, memory is a first-class citizen. So you always are able to actually find out things like the question that I just asked, which is, where is this value? The actual location of the value is something that is integral to C, and it's something that you can trivially find out, manipulate, use to your advantage, and those are things called pointers in C, basically. You can take the address of a variable or anything else in C, and the address is basically a number which tells you where in the memory of the machine that thing is stored. And you can have a thing called a pointer, which is basically something that just holds an address. It's like any other number, but the number
what presents did you get?
Is used to reference a piece of memory. And C will allow you to use that number to do things like go and see what's in the memory that it's pointing to. You can move them around to point to different things. You can increment them so they point to later values. You can decrement them to point to earlier values. And basically what this means is that unlike some languages where memory is not something you're really allowed to touch.
Bro, why did this guy give me £1?
So you can't actually go in and
Bro, did you steal your dad's wallet for that?
ask about the actual address of something or go into an address.
Be grateful. I'm grateful for your £1. But did you steal your dad's wallet, man? You have your own debit card. Yeah, but the money. I hope you're not gonna be in trouble for that by your mum.
And touch it, change what its values are, those sorts of things.
I
You always
appreciate
have
it.
to be using variables that are known to the compiler and they're known what they are and their types are known, that sort of stuff. That is not true in C. C is very fungible with memory and it allows you to do all the stuff that you want to do, and that's one of the reasons that I picked C and C++ to do this project in. First of all, it's the language that I prefer to program in, so that's a no-brainer, but it's also because it allows me to show you all of those low-level things, unlike something like that was a little higher level, in PHP or something, or Java probably, although I've never actually written anything in Java. You don't have that kind of low. That put the ampersand a little bit further than what we want to actually get the hex out of there. But it
Fair
is
enough.
just a number,
Fair
and
enough.
what that number is it is literally the number of bytes, which are 8-bit values. It is the number of bytes from the bottom of memory, the very first piece of memory, all the way up to where it decided to store test. So this is literally where in memory we are storing.
Bro. Fuck. I can do it without looking. Nah, she told gang has lost it again, bro. I didn't lose it. Bro's at the fucking door. Bro, the ghost opened my door. I need to find my shank. I have this glove from my MMA. I'm gonna go beat the shit out of this ghost. Give me 1 sec. Anyways, let's get back to this.
This particular value, okay? That's the memory of the computer, that's where it is. Now, when I say that, there's a little bit of a catch to it. And the catch is actually important. So unlike a lot of catches, when I say I'll delay this and I'm going to talk about it later, I'm actually going to talk about the catch right off the bat. And the catch is that in the old days, if I were teaching you this course in 1980 or something like that, on a home computer, let's say I was teaching it in 1986 on an
We're not in fucking 1986.
Amiga, which is one of my favorite computers of all time. If I was teaching it to you there, that what I just said would be literally true. It would literally be like a number that referenced the actual physical memory of the machine. But nowadays that's no longer true, and the reason that is no longer true is because
Virtual memory.
machines today use something called virtual memory.
I'm so fucking smart.
And what virtual memory is it's a way to allow processes to, things that you run on your computer, the code, to sort of cooperate.
I know this, man. Can we get to the actual coding bit, please?
So for example, but eventually through exact same it's around. It's just the stuff that's around. Hello there, memory. We're all having a good day today. So what I want you to be able to see here, if I actually scroll a little bit, right now, 3CF9AF, 3CF9AF right there. I'm going to leave the cursor on it so we can remember where it is. That is the location of our special value, pointing to here, right? If I want to, in the watch window, I can type, I can't type full C code, but I can type some things. If I want to, I can move it 1 byte forwards, right? It's just reserve this part of the virtual address space for you. That 3CF9AF was some location we could start writing to, and that would work. Gets you the memory from the stack. That code is actually done for you by the compiler where necessary, and so on. So it's just built into the actual act of compiling something in C. Now, that would not be true if you were writing in completely low-level code. If you were writing in completely low-level assembly, you would actually have to even get the stack yourself, and you'd get it in the same way that we're going to show how to get memory later in the mainstream. But for all intents and purposes, it's all you have to understand at this point is that the compiler is doing the work for asking function. So basically what happens is local variable some function in the middle, right? We're never going to call a bunch of functions and have a middle function go away first, because what would those functions return to? If I actually do that, right, if I go here, void bar, right? Wow, typing skills today. Too much talking, not enough typing, Casey. I hear you.
Exactly.
If I ever make one here, if I make a function bar here, and here is my variable, right? I call that from this guy. So now what we're going to do, right, we're going to go in here, and we're going to say test, right? I want to call foo. I call foo. I hope you can see the little arrow there. I don't know if it comes through on the chat. Okay. We're going into foo. You can see bar, and now we go into bar. We return back out to foo. We return back out to main, and we're done with the program, right? It's always like Russian nesting dolls again. It goes in, and it comes back out. One thing, actually, you know what, too? I'm gonna do lazy internet here. if someone knows how to make this highlight this the line that I'm on really boldly when we're stepping through so people can watch it on lower quality streams easier, please email me because I would love to set that up, but I don't know Visual Studio's settings that well, and I can see this little arrow just fine, but other people might not be able to see it. So if someone has an idea for that, please send it to me, and for next stream, I'd love to get that in there. So anyway, so that is how a stack works. And what's so interesting about this is we can actually just see that in action right now. It doesn't have to be abstract for you. Basically what happens is we go in here, and we're going to look at test pointer, and we're going to see where test pointer was. Now, okay. And we're going to set that 255 value, and we can see it right here. There is our value, right? So now the
Okay. So I have to manually click step into. Why is the value this? What? Why is that the value?
interesting thing, well, you know what? Let me back up just one step. I want to make this a lot clearer. So I'm going to go ahead and get rid of some of these things here that we were playing with before so that I can show you something a little clearer.
I'm not getting a Windows Manager. Can't be asked.
So we're going to make bar be 100. We're going to have that variable there.
Well, I can be asked, but there's no point.
We're going to make another variable here. We'll call this foo variable. We're going to make that be 200. We'll call this bar variable. There we go. And we're going to have our test, which is out here, right? Make sense? Pretty straightforward. Oh, but you know what? I'm doing it again. I always do those inline declarations, and I apologize. We're not. It's nothing special. It just actually does the assignment on the same line as the declaration. We will talk about it in, eventually, and it'll be fine. But you get the idea. There we go. Separate lines now. Everyone's happy. Okay. So I'm going to go ahead and run this. And we get down and we stop at our familiar location, and I'm going to look at that address. I'm going to say, please give me the address where we're going to assign it. We step over that line and we see the 255. There it is, just like what we wanted. But now we can see a little bit more. When we step into foo, right, here I go, I'm going to set this foo variable to equal to 200. And so now what should be happening if this stack thing that I said is true that I just told you about, right? I should be able to find where it's going to stick that value, and it should be close by because all we did was kind of grow a little bit there. So let's see if we can find it. I don't know if it'll actually save it for us. Let's see here. That is foo variable. It is at 790. So where is 790? 790 would be right there. So there it is, right? You can actually see it right there. And our previous value that we were looking at before, the test pointer value, was 87F, which is right down here, right? And it's at 0 because we wrapped it. So there is the value that we had written to in this function. That was where it was on the stack. And then here is the next look.
Wait a second. We can actually connect with database.
Location on the stack. Now you may notice that there is full banana cake stuff happening here. Like, where did all this other stuff happen? Why did it
bro say banana cakes?
Why did it put them so far apart if this stack is just growing? And the answer to that is actually because there's all kinds of shenanigans that actually go on with the stack in debug mode, which is what we're compiling in here, where you can, basically the compiler has settings which put stuff in there that try to help you from making a mistake. It'll basically put in stack frame checking and padding regions and all these other things to try and help you from errors where you might be writing if you're actually doing some of this pointer manipulation that I was doing. So a bunch of this stuff we don't need to worry about now, but basically what's happening is when it pushes the stack, even though it really only needed to go a little bit to store this one simple integer, which is only 32 bits or whatever, we only need to store that one thing. The reason that it was actually pushing so much stuff on is because of all that extra stuff that happens. So I have maybe just a little bit of time left before I go to the next thing that I wanted to talk about. So I'm just going to see if quickly, and the reason I say I'm going to see if quickly is because I don't use Visual Studio for compiling hardly ever at all, like I was saying before. So it's going to be a little hard for me to find the right thing to set here. But if I can go in here and set to an optimized build, I may be able to show you that stack a little more concisely. So I'm going to see about that. I'm going to try to stop doing that. But suffice to say, what is happening in there is that it's pushing extra stuff on the stack. So that is where all our memory is coming from. And one thing that you may have noticed is when I ran this program multiple times, the memory that we looked at the last time, like remember last time it was there, this time our memory is in a completely different place. And you may wonder why that is. That seems kind of odd, right? Because, I don't know, aren't computers deterministic? Why is it randomly picking memory? The answer is because of security. It used to be the case that if I ran the program multiple times, the memory would be in the same place. And this was actually very convenient for debugging. And sometimes it's a good idea to shut off the feature I'm about to talk about, specifically because it makes debugging easier because all your memory will be in the same place. But what happens nowadays is that because the fixed layout of things in their virtual memory space when they would run allowed hackers to be able to do stuff like know exactly where an important thing in memory for that process was and use code exploits to go grab what's in that memory or reset what's in that memory or do other things like this, or to know the place to branch to in code to do things. Basically, it allowed them extra flexibility that they wouldn't have had otherwise. Because of that, it became a thing that they do now where they randomize where your program actually runs.
Like
I think it's called address randomization extension.
In a long time.
It's got a name in Windows. They gave it a name. Address space layout randomization. And basically what that, I know it sounds crazy, but that is all we will do. And so I really want to drill these kind of fundamentals in for anyone who's talking about it. I was going to mention it again a little later. Unprotect the memory. Virtual memory system is each of those pages that I talked about. And we may look at turning that off in the future just on the dev side of things so that we don't have to actually deal with those and they'll be at the same place, which will make it a little easier for me to show things. So that is how that works. Hopefully you're very comfortable with this now, and you've seen it's not that mysterious to understand these things. It's really straightforward. We can just look at what's happening in the memory. We can look at how our program is working, and I'll be honest with you, every single thing we do starting Monday, everything we do for the year or two that it takes us, that is crazy, but that is all we will do. And so I really want to drill these kind of fundamentals in for anyone who's unfamiliar with them, because once you get them, you're like super powerful. You can do anything you want, and you can build your own anything you want. And from then on, you don't have to deal with other people's abstractions. If you want abstractions, you can make your own, and you can make up what the rules are. You don't have to follow someone else's rules. You don't have to follow what the people who designed Java thought were good. You can follow what you think is good. And that to me is very empowering, and it's really great. So the other thing that I wanted to do today, besides kind of showing you where that's actually going so you can understand what that is to quickly mention that we talked before when we went to the assembly, right? We did this, and I went to the assembly, and I said that we were going to talk about it. I was going to mention it again a little later. This number right here is also a hexadecimal.
It's because I'm using Brave browser.
Location in memory. So if you want to, you can actually copy this piece of thing as well, and you can go to one of those memory viewer windows that I was talking about, and you can paste in the location of the memory viewer windows that I was talking about. And you can paste in the location of the code. So you can actually say, oh, I want to see my code now, right? Oh, and awesome. As I say that, apparently that's a total lie. Apparently you can't actually look at the code.
You can, because I just did. I just did that.
Presumably because that is actually not allowed by the memory protection of this particular thing.
It is allowed. I just did it. It's right here.
All right. Do I actually go unprotect the memory? 644. I can't do it. Okay. So I'll simply say why you weren't able to do that, and then maybe I'll go do that for the stream tomorrow night so we can actually look at it. So I am thwarted by the virtual.
Wait. How is bro making the stream 2 times faster? Are you like going into the future as well?
Memory system. Basically what happens is if you have actual memory that's executed, in the old days again, and even not too long ago, maybe even 10 years ago, let's say, 5 years ago, I don't know, that would have worked. And I've done that before. I haven't done it recently for, I've actually done it recently with code but it worked there for a totally different reason that I won't go into. So basically the reason that I can't do that now is again because of security. And what they often do, at least I'm assuming that's why, I have to go investigate to verify that's why, but I'm assuming that's why. What they actually do with the virtual memory system is each of those pages that I talked about, and we'll talk about this a lot in the mainstream actually, but each of those pages actually has things on it that the CPU understands that are called flags, and those flags allow access control. They basically allow you to mark a page as being readable by a process, writable by a process, executable by a process. And what they do now to prevent, again, more hacking problems is they will mark the pages of your code that are executable as not being readable or writable. So pictures today. We have pictures. And what I said is today's stream was going to feature the motherboard from the trailer. And one of the things I did when I was trying to, I've been sort of working on this project, getting this project going for about a month or two. I don't even remember how long. Since people asked me to start doing streams, basically, I was trying to do like, what am I going to do for a stream? I was like, I got a good idea, I think.
I heard lots of reviews about this guy online. They say he waffles so much.
Times 1024, so that would be kilohertz, times 1024, which would be megahertz, times 1024. So now we are actually up to gigahertz, right? So there's the number. So take a look at that number for a second, right? And now take a look at this number for a second.
Why are we looking at the speed of light?
It's not looking so great anymore. And if we actually have Google do this math, and I think it can actually do it directly, speed of light divided by 3.2 gigahertz, right? We end up with that number, 9.3 centimeters, okay? Now, just to be clear, what a gigahertz is that's the smallest, it's called a clock, basically. CPUs have sort of ticks where they do their operations. So basically, inside of one clock, right, one single tick of the CPU is the fastest that it really can do anything. It can't do stuff at faster than a clock. Sometimes it can do 2 things in one clock cycle if it has started multiple of them going, or it can issue multiple things, but the results won't come in for at least one clock cycle.
That makes sense,
so like between the time when it has to start something and the time when it has to finish, it's going to be like at least one clock usually, unless there's crazy shenanigans going on.
You clogged the toilet. Yo, give me proof.
In there. So what that means is that the CPU can actually at least possibly do one thing, or possibly a couple things, depending on the circumstances. It can do one thing at that speed, 3.2 billion times a second. So what I'm going to look at here when I divided the speed of light by that speed, which is 3.2 billion, I wanted to see how fast does light go.
Oh, you wanted me to punch the PC. Why didn't you put it in the tip message? I completely forgot. I can do that. It's not a problem. Done. £1 well deserved.
In the amount of time that it would take the processor to do one thing. And the answer was, something like 9 centimeters. Now, I suck at hardware design and I also suck at math. So I may have typed this in wrong or whatever, but I think that's about right. People out there who are good at math, you're welcome to
If this guy sucks at math, I think we should all just kill ourselves at this point.
correct me. One of the things that people often say is that people who are good at programming are good at math. It's not true. I suck at math. Anyway, if we go back to our ruler here, that 9 is like there to there. That's the speed of light. Light can only go from here to there in that time. It can't even get back in the time it takes the CPU to do something, okay? So when you count up all the actual logic that has to happen and the fact that it's not a straight line and it's got to go through stuff in here, right? And it's got to go through stuff in here. That's crazy expensive. Even if it was literally a part of photon could not make it there and back in the time it takes the processor to actually do something. And the reason that I think it's important for you to understand that is because that is why memory is such a big deal in optimization now. Going out and getting things from memory is a huge deal. And to finish the story, I have friends at Intel, and one of the things that I asked one of them at a time, I just said, why is memory so slow still? Why is memory such a bottleneck? What's the actual hang up? And the answer that came back was wires. They were like, the amount of time, it's physically far away is the problem. And, no surprise, one of the things that people are working on technologically right now for future generations of CPUs, I don't know if it'll happen or not, but certainly I think, NVIDIA was doing it and Intel is doing it, a bunch of people are working on it, is something called stacked DRAM, which is basically RAM that sits on the CPU. So it doesn't have to go out here to get it. And so the question is, can they get sufficient amounts of RAM, stuck on right on the CPU so that that sort of speed can be.
Unless they make a RAM that's boxed shape. They make a RAM like a square and they attach that around the CPU.
Can be improved, right? And so what I also want to say here is, I got another picture. This is the same motherboard, but I rotated it 90 degrees and placed the ruler going the other way. So this piece right here, that thing, that is where the graphics card sits. You plug the graphics card into there, all right? So if you want to send something to the graphics card, well, it's got to go out to the memory first, probably, unless there's direct bus stuff that happens to the graphics card, which would be, here to here, let's say, or something like that. It's got to go out to the memory, and then it's got to go to the graphics card, probably. It's going to have to do some round trips there. Or if it could do some kind of weird bus mastering stuff, like I said, don't know hardware design, not going to pretend I know. But basically, you're dealing with something that operates in this triangle, and that's huge again. Speed of light, again, huge problem. So that is why you have also huge bottlenecks in terms of the speed at which you can actually get something to the graphics card and back is also a huge problem. There's all these sorts of things that conspire against you when you're talking about these physical separations.
Cool, man.
And it makes things pretty hard to do. I've had maybe hundreds of things going through. I got a ton of different things in memory. I got to go. I don't really have to wait for each other or swap things in and out. Each one of these things can be executing stuff at a time. So each one of these cores, the main memory, are additional. It actually mapped and translated by the CPU. So you've seen it all today. You've basically seen everything. And everything I'm going to do, even in the two streams for the practice streams for Saturday and Sunday, everything I'm going to do from now on is just how we manipulate that memory. Every last thing, everything. It's all about that. So I hope that is something that you will keep in mind and that will be easy for you to relate to as we get more comfortable with it. It'll just be something that you just think about and know, and you won't really have to worry about it. It'll just be part of your daily programming, and you'll be good. So thank you, everybody. We've got 230 people, I guess, on here, which is crazy. This was not the regularly scheduled time because on Fridays, I think I'm going to probably move the times around to give people in other time zones a chance, and also because, if I want to go out with my wife on Friday night, for example,
Blood has a wife. We are all saved. I'm joking.
Continue our intro to C. Okay, hello everyone, and welcome to the 4th day of the test stream here, where we're doing a little introduction to C.
Yeah, I said wife. I said, if he has a wife, then no one is cooked, right? Everyone's chilling. If electricity has the speed of light, why don't they just point massive lights at the motherboard to boost it? Low taper fade. Oh damn.
Yesterday, we got to do some fun stuff. We sort of started to really, no, you just forgot the blah. And it's like, very good. So I really appreciate that, whoever that was. Thank you very much. I know it was Matthew Vandevender who actually posted it at the end of the chat, but I think he said that it was someone else who had said it earlier, like at the time. I don't read the chat during the stuff because it'd be too distracting for me, but I read it at the end. So anyway, that's just the one thing that I wanted to correct. And it's not that big of a deal. You will rarely be doing that with code, but I just wanted to show you that it is there because, again, one of the main things that I could keep harping on through this entire series is just always saying everything's in memory, everything is just talking about how to
Did they use a rubber?
get things into the C code. Any given instruction is fixed.
A rubber room with rubber and rubbers. They give you rubbers. Well. What else is crazy?
So if you have an instruction like, move this to here or whatever, or add this to this or whatever, like we've got, those would all be the same size. It doesn't matter what the instruction is. They're always the same size. And that, that would be like, I believe on, for example, PowerPC, that was true. So like, on a PowerPC, every instruction in memory as it's encoded when it, when the CPU is reading it out of memory, those instructions are the same size. But on Intel CPUs, kind of keeps poking out at us. So it's going to move that 255. It's going to move it to this location, the test location, whatever the address is of test. It's going to do that move. That is encoded as 4 bytes here: C6, 45, FB, FF, right? And hexadecimal, again, which we'll cover in a little bit. Each letter is basically 4 bits. So if you see 2 hexadecimal letters or numbers, you know that you're looking at 8 bits. So this is 32 bits right here, kind of thing. We were talking about the stack. I actually even had some notes here. I want to go over sort of looking at memory in a little more detail in terms of what C, talking about memory so much, maybe we should even maybe we should address this location 500. So let's see what happens. Step. Now, did you see those two change? It was these, right? So a math whiz. So if we have 500 and we subtract 256, we're left with 244, right? And so if we want to do 244, we can go ahead and set 128 as well, right? And then we'll subtract 128 from it.
Blood is currently doing nothing.
So now we've added 5.
Because this guy, Moy Rocket, is like the biggest yapper I've seen in my life, man. Yeah, if you want to go earlier in the stream, original, you can see like, unfortunately, I've lost it and I've recorded it live. There's nothing I can do about it now, but yeah.
We've added 256 and 128. We're left with 116, which is still higher than 64, so we can set that, right? So we'll set that, there, 64. We're down to 52. 52, still higher than 32, so we got to subtract 32 from it as well. Down to 20, 16, still there. A very high number, you're going to add something in the high order byte because they all correspond to things after that. It goes sequentially, right? So this will be one higher. This math should be right? It's 1 byte plus 4 bytes by 4 bytes.
What do you mean, why am I bald? I'm always bald. I've always been bald.
2 bytes is 11 bytes. What's wrong? What happened?
I know, Mika, just remember, or what's that phrase? What's that phrase? $20 is $20. You know what I mean?
What's weird here, right? And the answer is, like I sort of started saying before, is that the compiler is not under any constraint to lay this structure out as compactly as possible, if you will. It is not necessary. It doesn't have to do that. So what it can do is, if it thinks it would be more efficient because of the way the CPU accesses things, for example, and the instructions it has at its disposal, if it thinks it would be more efficient, for example, to reserve 32 bits for each of these, because let's say the CPU is much slower at accessing an 8-bit value that is unaligned, that's like kind of at a, that's off of a 32-bit.
What is this guy talking about, man?
What we actually see, we don't have to do that at all. I can do some.
Yeah, so look, for example here, right? we did this calculation with because of we got 1 byte from the character, 4 bytes from int, 4 bytes from int, 2 bytes from a short. We got 11 bytes total here. Why are we doing that calculation? We're not making like NASA spaceship applications right now. $20 is $20. Just say you're gay, dude. I'm not homosexual. My friend. I am heterosexual. I don't know what. Couldn't watch as I was playing Roblox with a friend, which at my age, I suppose we're going to some sort of list. Yeah. I mean, at your age, you're like you're like 50 years old, original. I'm pretty sure. I mean, at that age, you got to be making games, not like playing them.
And there's no way to do anything else with it. I don't have to do that at all. I can do some pretty fantastically wacky things if I should want to, or if they should become interesting for me to do. And so I will show you a little bit of that now.
I'm not gay, but $20 is $20.
Let's say that what I really wanted to do is look at this structure as if it were a series of shorts, right? So what I want to do is I want to use the pointer thing that I had referred to in the previous stream. I want to use a pointer called, let's say, Mr. Pointer Man. And I want to look at test as if it were a bunch of shorts. So I'll do the assignments first. I'll put these on there.
Why doesn't he just use a struct? Oh, he did. Oh, no, he didn't. Oh, he did. No, he did, yeah. All right. Yeah, okay.
I'll actually do the assignments, the one, and you know what, I'll make it so that we can tell which one's which just by, you know, assigning a different value to each of them, let's say. And what's going to happen is I am going to ask to see, I want to basically look at the memory occupied by test as if it was just a bunch of 16-bit values instead of looking at it in the way that it's laid out here by name. Now, in order, C is a statically typed programming language.
Yeah, so you need to put the type as projectile.
Is what it's called. That's the type of language it is. And static typing means that
You can probably skip straight to when he starts making something. I skip through his videos whenever I need something. He goes for a lot of detail. Yeah, when does he start making the actual thing? Watch car dumped. Called dummy. Right. When does this guy start doing something?
to pick one of these projectiles. The reason that I say that they're essentially the same and not exactly the same is because of damage to 60. He does when it does up above, right?
Does anyone know when he actually does something?
Okay, here we go.
There's nothing I can do about it. It's all light themed. HandMade Hero. I thought this is HandMade Hero. Is this not HandMade Hero? Day 5 of the Introduction C Programming on Windows series from HandMade Hero. I think this is HandMade Hero. If it isn't, then I'm the silliest Billy in this world.
So, someone asked a question in the fix out an executable. Boom, the A moved, right? It puts the little green, yellow. It is no longer incumbent. The same as taking the declaration of what star pointer was. Structs with pointers in them.
I think it is, but this is like the early test streams before doing the proper. He made some normal C tutorials. Ah, okay. You know, that makes sense. Oh, damn. Oh, damn. Look at this. So day 5, he finishes at day 5, and HandMade Hero actually starts here.
I'm going to go ahead and hit the start
Oh
record
my
button.
days.
And I'm going to minimize OBS here. And I am going to welcome
Oh, I didn't know that. Oh. Man, I've been wasting so much time. You know what, board game maker? You know what? You saved my ass. Cause I was gonna stop doing it. Oh my.
everyone to the very first episode of HandMade Hero.
If you wanna watch Core Dumped, go watch Core Dumped. I like Core Dumped as well, but I don't wanna watch him right now.
I am super excited about this project. I was thinking that this was going
If you're excited, let's get the fuck on with it right now. Come on.
to be basically turns it into parts set up inside Emacs. And like I said, this is going to be the drudge work. In fact, tonight will probably be the most drudge worky night. It's too bad to start off the series with the drudge work, but hey, this is where projects
I don't want to use Emacs.
actually start. There's nothing you can do about it. So I am going to go ahead in here, and inside Emacs, you know, there's all kinds of stuff I can do. I'm not going to explain all of these things because, again, I don't even necessarily encourage people to use Emacs. It's just the editor I'm fastest with. So I think you should all use the text editor that you're fastest with.
NeoVim.
But hey, if you really want to follow me, you can follow me and use that .ems file. So I'm going to make a directory in here. I'm going to make a directory called code. And inside
Okay, well, let's just delete everything that I've done then and start from 0. I mean, I could load this up on my Arch Linux SSD, and I could just do it on NVIM, and I think I will. But then that means I'd have to end this stream. Right, I'll just start here then.
inside that directory called code, I am going to
Or I could put it on this disk, and I can access this disk on the Arch Linux install as well. I think. Can I? I'm not even sure I can.
make a handmade, actually I'm going to call it win32 underscore handmade.cpp, right? Now I have Emacs programmed to insert a little header into each of these, and what this header actually is...
Wait, oh bro, I'm so stupid. How am I gonna make a Windows app in Arch? I can't believe I just said that. That's mad. No, I have to obviously stay with Windows, unfortunately. That is crazy that I just said that. Right.
This is
Win32 underscore handmade.
This is sort of a little bit anachronistic these days, but I'll tell you what it is. Basically, you know, inside a comment, what it basically does is it says, hey, I am going to actually put little markers in that some external tool could come along later and fill in the file name, the date of the file, and the revision if it was checked into source code control. So list colors display, let's take a look. Those of you who were with me at the beginning of the stream, I greatly appreciate your help figuring out exactly what the color should be for everything. So I feel like one of those grays looks good. Maybe a gray 50, let's say. Gray. It is basically the documentation for. The whole point of this series is basically to give you all those things. Actually be that in just one and watch that intro stream because it will teach you how to read these things.
Okay, and if I remember correctly, right, it's G++ Win32 main.exe. I think, but I didn't even put anything in it. Yeah. So let me just what can I open it with? Do I have any good software? No, we do have NeoVim on NeoVim. One sec. NeoVim Windows. Uh, I need to upload my Neovim get config and download it on my Windows. It's going to take quite a while to set up, so I'm not going to do that now. Let's try this again. Alright guys, that's going to be the end of this stream. Fuck. I didn't put these things in. Right. H instance. Okay, it worked. I'm joking, I'm not ending this stream. Right. So it's all good now, we compiled it. Now we've got to see, where's the exe here? Right. So you go to exe. I have a program here, guys. Right. Main.exe. If you want to buy it off me, send me 2 bitcoins and I'll send you the exe file. This is my Code Gibbs application. You know what I mean? It's got to be worth like quite a bit of money.
So that you won't be confused by that. So, and it's all, I should also say, if you go to handmadehero.org, it's on this archive button. This archive button right here has all the stuff, intro to C on Windows, that sort of stuff. So if you're totally new to programming and totally new to C, you definitely want to start there. But assuming that you know what this stuff is and could read C reasonably okay, or at least a little bit, basically what we're doing in here is we're including a header file, and that's just a bunch of definitions of functions we can call and types we can use that Windows wants us to use to communicate with us. And
I wish I knew this since the beginning. This stream would have been much better if I knew what
is going to be an entry point where Windows will pass us a handle to our executable. This set to going to be doing stuff. And build tools for optimizing the build tools that optimize your build tools. They love it. I don't love it because usually what I find is I spend all my time screwing with the build tools, just trying to get stuff to build. So I just said, screw it. There's no more build tools. There's a batch file. There's just a batch file. That's all there is. And the batch file compiles the code. It compiles all the code every time. Now, the reason that's going to shock and horrify a lot of people is because they're going to be like, oh my God, you compile all the code all the time? The whole point of a makefile is that you only compile the code that changed. And that's what a lot of those build utilities do. They try to optimize things so that they only do the minimum amount of work necessary to rebuild a project. And when projects get very large, they can get very slow. But I have found that actually, if you just code sanely, I now compile very large programs, certainly larger, considerably larger, than what we will take to make a good, full professional quality game on this stream. Much larger, by just using a batch file, and it's only a couple of seconds. So I think the time has come for people to maybe start rethinking the way builds work, but, you know, again, like I said, just me. So what we're going to do here is we're going to start with a line that's at echo off. That is nothing other than basically echo off is a command. Really bother using a make system or anything. What other programmers like Ninja, because there are real ninjas in the world. Here you go, a small build system with focus on speed. They use.
All right. Well, I know what I'm doing tomorrow. That's gonna be it, the end of this stream. Yeah. Thanks everyone for watching. Good night, Mika. Good night, Original. Nah, I can't be listening to a 14-year-old man. But obviously, as I said earlier, £20 is £20. Anyways, good night, everyone. Have a nice day. Have a nice night. See you tomorrow in tomorrow's stream. Actually, when is tomorrow's stream? When is tomorrow's stream? What's this? Evening. All right. All right. I'll see you guys tomorrow in the evening stream. That's when I will be here. Obviously, check out the schedules and that. So yeah, see you next time. Peace.